Hello, thank you for checking out my video today. Today's video I'm going to talk about single stepping the bus on an 8086. Now single step in the bus, what I don't mean single step in the processor. I'm talking about in the bus cycle, there is a T wait cycle, that clock cycle that is, that waits for the IO bus to be ready. And so single stepping it, I'm just going to wait in that wait cycle until I'm ready, and I'm going to activate that by pushing this button here. So the reason for this is I've got to build a bus controller from 8086 project in order to be both 16-bit and 8-bit compatible on the ISA bus. And I want to do this out of logic. And so this is kind of part of that logic process, is to be able to hold it in that wait cycle as needed. So this can be done on an 8088 as well. The hardware is pretty much identical, except for, of course, you would not have the full-size 16-bit bus. You'd just be having the 8-bit bus. Let me talk about the layout. All these LEDs you see here, they're the address bus. I want to be able to see what's on it. I've got my upper odd byte for the data bus here, and I've got my even byte for the data bus here. And I've got my processor card here, and this is my heavily modified 8086 processor card that works in 16-bit mode only. That's why there's chips missing out of it. But it's in a ISA card slot here with my extension to communicate with the board. Made it a lot easier than trying to wire the whole thing up on the board. The other side, I do have 4 LEDs. The upper two there is memory read-write, and the lower two are IO read-write. Those are just for status. They're not really for anything else, just other than to see. So I'm going to talk about how the wait state trigger kind of works. I may include a schematic one day on this, but I'll try to explain it well enough that maybe somebody can copy it if they want to without needing a schematic. So I've got an LSO4 here and a 74 LS74 here. The LSO4 is only used for one purpose. So coming off of the processor, I have the address latch pin right here. And that's what initiates the bus cycle. So I bring it here and I just invert it. And so that's the only thing that the LSO4 has done, is for inverting the address latch. So instead of a high, it's a low. So on the 74 LSM4, I'll just start at the top here. The clear, as you can see, is connected to the 74 LSO4. The address latch inverted goes to the clear. So that clears out the 74 LSM4 of anything that was going on prior to the bus cycle starting. The D data pin I've just got connected to 5 volts, so pin 2. Pin 3, the clock. Now this is our this is what triggers saying that I'm ready. And so the pin 3 there is connected to my push button. And the push button, by default, the clock is held low with this resistor, and the push button just pulls it high. The push button is not great. It sometimes triggers it twice. It's not a glitch in the system, it's a glitch in the trigger. So we'll talk about it a little bit more. Next one down, I've got the preset. This is, I've read, is kind of like another clear, and I'm using it. It's tied to not Q. So this is what stops the 74 LS4 from continuing anymore once it's been triggered once. And the Q right here is connected to the ready pin. And then, of course, I've got my 5 volts and my ground, and I put a decoupling capacitor on there, and that really made a lot of difference right there. I was having all kinds of issues before I added that. So I'll demo it here. Let's hopefully I didn't bump enough stuff. And I'll just hit the reset button. So, as you can see, the upper address lines are F. 8 through 15 is F, FF. And then, anyway, it's FFF0, and that's correct. The system bus right now is now being held, waiting for the ready pin to say I'm ready. My data I have set for the nope opcode, so 90 on both of them. And we can just step it now. Hopefully this works without double stepping. So I'll just tap it, and you can see A1 just turned on. A0 will, it'll turn on, but in this case, you'll probably never see it turn on because it's reading a full 16-bit every time, so A0 is not used. Should mention this LED down here, that's bank high enable. So I do have that available to see. So now we can just single step through, and it'll just single step forever. No opcode, no opcode, no opcode forever. If you change this to F4, of course it'll halt. Now, what I've done is I've actually added my Raspberry Pi here, if you can see that. And I've just been using the Raspberry Pi to toggle the ready pin. But prior to toggling it, I've got some, this is through the SPI bus. I've got these wires here coming from the back side of the card there. And this is your memory read-write and your IO read-write. And address 0 and bank high enable, so that I can get a status before I toggle the ready and step it. And this is just kind of more just to see what's going on. But this could actually be used to create a Raspberry Pi driven bus, but I would imagine to be extremely slow. That's why I got to make it out of logic. I'm going to demo that real quick here. Just reset the system. Let's see if I've connected it right. May have bumped a few things here, but let's see if we can get it to work. All right, got it to work. So you can see I'm not pushing a button, it's just counting up using the Raspberry Pi. And conveniently, because I have those status lines there at the top here, I am able to get a readout of what's going on. You can see that says read word from memory. And it'll just say that forever. I'm going to hold the reset button, and I have in there, it'll say no bus action. So it's not requesting anything. Let go again, and now it's going to start over, reading word from memory. And it just pauses for a second. It's only slow because I put a time delay in there. And at full speed, it's still not full bus speed, but it's pretty quick. I'm going to demo something else here. So I'm going to change my value here on, I'm going to hold the reset button while I change this. I'm going to change the value on the lower side to E6. Now E6 is right, I want to say it's right AL to port, to a port. The port being this other value here. So we'll let go. You can see it counts up, but then all of a sudden it drops, and it counts, and there's some values. And you can see there's 2 lights lit up, which is 90, because this one still says 90. So it's writing to port 90, and you can see bank high enable goes high, which means it's not being enabled. So it's writing 1 byte to the lower port. And up here on the screen, it says the same. So you can see read word for memory, write lower byte to IO, read word from memory, write byte to IO. So, and that's what the opcode is giving it, and that's what it's doing. So anyway, so hopefully this has been a good demo of how to single step the processor, the bus, using an LSO4 and a 7474, and that's pretty much it. So anyway, thanks for checking out my video today.